This next and final section is going to cover some of the miscellaneous tools that the Sleuth Kit offers to be able to get some additional information when investigating a disk image. So one that's really interesting is this icat command. The icat tool is used to output data directly from a file into like the command line environment, or you can also output it into a text file or any other kind of file that you specify. And it will work on allocated and unallocated files, and you will need that inode value for this tool if you're using it on a partition image. If you're using a disk image, you would need that offset value and the inode value. I will go ahead and use it on one of the partition image examples because we can pull the message from that deleted file straight into the command line environment without having to recover the entire file system just to view that one file. We'll just go ahead and remember that the inode value for that file was 3, and we'll go ahead and conduct using the icat command, and we'll do river.img and we'll remember that inode value. And that will go ahead and just print the message right then and there. Don't have to do a TSK recover. Don't have to go back to my local computer's directory or file system, look in the directory that's located in to find it or open it. I can just print it right there. Like I said earlier, you could also output it. And this is just slightly pointless because it's already a text file, but just to demonstrate the concept, you could change, put it in like secret message.txt. Then the Sleuth Kit would create a file called secret message.txt and output what it gave us in the previous step into that text file. So if we go here and we look at the directory, we'll be able to find that text file. And so we'll have to navigate out of this directory that we were in from the previous example. And we can see here that the Sleuth Kit did indeed create this text file, and it put it in the current working directory, and we can go ahead and open it, and it's got that same message as we saw previously. So this is kind of useful if you happen to stumble across just this like a text file that piqued your interest, but you don't want to have to recover the entire file system just to see if it's worth anything. So you can just go ahead and output it into the command line environment, or as demonstrated, you can just go ahead and throw it into another file which will be created for you by the Sleuth Kit. You can just go back and navigate and find that one file, open it, and see if it's anything worth recovering the entire file system for. And so again, it's just kind of like a little neat tool. Next is the ffind tool, which again is also a pretty interesting feature that the Sleuth Kit has. If you have like an inode value, you can use that and the ffind tool to figure out the name of the file or directory and the location. You can actually get the exact path to that file based on the inode value. If you just happen to stumble across like a random inode value and wanted to know, is it worth anything, you can use the ffind command and be able to determine if it is or not, or you can at least be able to determine the path to it and then be able to go and look in it. If you do a TSK recover, you can just navigate through to it in your local computer's file system. We can go ahead and just run this command. This is going to be using the full disk image, so we do want that sector offset value. It's always important to be able to run anything on a full disk image. And then this example used the number 459, which went to a directory on the system. And so if you wanted to know more information, say you just had the inode value, you just used the ffind command to find out what the name of the file is and where it is, but you just kind of wanted to know some more information about it. Well, you of course can use the icat command to look further into it. So you can do the whole command, do the inode value, and see what you get. So just based off this information, we can see it is an allocated file. It does not appear to have gone through a name change on the system, as it just has the one name, and it looks like it hasn't been touched since August of 2004. And you'll get just kind of that basic information on that directory, as it says it is an allocated directory in the output. So that's just kind of like a neat tool. You can really, if you wanted to, just sit there and just type in random values and see if it comes up with anything. Did like -o, cc3, name of the disk image, and then if you wanted to just randomly type in like 128, see if it returns anything, and it does. So it can be just kind of a fun tool to play around with as well. And then last but certainly not least is the TSK LoadDB tool. So what this tool does is, as you can see, it will upload and store the metadata of a disk images file, so the entire like file system. It will upload the metadata of it to a SQLite database that the Sleuth Kit will create for you. It will literally create a database file for you into your current working directory, or it'll put it where the disk image is located, is really more accurate. If we wanted to do a load DB on the full disk image, we would just have to do TSK load DB and then do the you won't need this. This is one of the few tools you would not need the off sector value for the full disk image, just because you want like the whole thing recovered or uploaded to the database. So the partitions don't really matter too much at this point with this command, but we'll go ahead and just enter this, and it will let us know if it's successful or not. You don't have to like specify the name for the database file. The Sleuth Kit will just go ahead and automatically default it to the name of the disk image file. So as we can see, after we hit enter, it will take a moment just because it's a large disk image, but you can see here it made it schartd.dd.db. So it just went ahead and goes ahead and names it after the disk image file name. If we go back, we can see that it did create that database file. It's right there. There's not a whole lot we can do with that currently, but it is just a good tool to show, because you can take the database and use it in other applications to investigate the file system if you wanted. So that is pretty much just the overall walkthrough of the tools that the Sleuth Kit provides, and it's a good introductory lesson to how to get started on investigating a file system or a disk image, understanding the tools, understanding what they're saying, understanding what they're doing, and then being able to efficiently investigate a disk image.